tomorrow there's going to be at the end of the session, some of you have heard that T is going to come back and talk about a couple things because people weren't here yesterday. And Kathy, I think, may come back and spread a little seeds for the future, as it were. And so my plan today is to open up with questions that you have and then dive into, I would really love to get through all the three types of arrays or lists, the three algorithms that work for them. And it'd be really fun if we can get to the Boolean one to talk about the simple Aristophanes, which is really super cool.
Don, will you be talking about tuples at all? Because that's one thing that confuses me.
In all honesty, not here during this time period, probably. That would be one of the things, since you brought it up, this is a cool way to interject this or slide to this piece. The group yesterday was talking about potentially getting together and doing either what we used to call pop-ups, which was like a little session. I would go down to Eugene, or I'd go down to, and other teachers did this too, but mine, I would go down and do a 2 or 3 hour little session on some topic that this group of people wanted to cover. So one of the possibilities, if you're interested, and Kathy will be talking about it at the end, she's kicking out a survey. If you guys wanted throughout the year, we could do that. For instance, Mike, Kathy's already signed Mike up, and he didn't even realize that, but he's doing so the Google Translate, so to do verbal stuff, and then you can write coding relative to that. He's playing around with that. He was dumb enough to mention that, so Kathy hooked him right away and got him. So in several months, if that was a topic that people wanted, we could do a discussion on that. The other piece of that, or another version of that we could combine or mesh whatever way, was just to get together and share and ask questions about teaching, how to do that, what's going on doing a Python itself, just going either pedagogical stuff or with you guys having to do all this stuff online, to share and have a time to share. And since you have to be clocked hours on, see, this would be doing technical school related things. So you could rationalize or justify either way you need to do that with your administrators. We could set that up. Oh, now the third piece of it was if people are interested, and once again, there seemed to be some yesterday, but I haven't got it formally. And the students asked me for stuff, and I said, cool, if you talk to me tomorrow, I'll start doing that. And so if they remember it that long and are still interested by tomorrow, then it's worth my effort to do the job. If not, if they forgot about it, well, then there's no point. There's no point. So this same thing goes with creating, I have several versions of things, but I would merge them together and put them for like a day-to-day lesson plan relative to teaching Python. And I could code it in such a way that you could either do like a middle school cursory, like just the graphic stuff and do that, or you could intertwine that with an actual full year course, even pre-AP course, pre-whatever, your first. And so you would have worksheets and quizzes and tests and homework and the pedagogical kind of flow. And then all I would ask is if anybody chose to do that, that they improved it. You guys, we just kept like a running, growing amoeba sort of structure with this thing so that it kept getting better and better. If you are interested in that, email me, and then I will start, like, kind of been doing some stuff already, but I will formalize that and kick it out for people. Probably in like a chunk. I would do like the first month, I could get that out, and then I'd start adding to it, and we just expand it that way. If you interested. If not, that's cool. I'd much rather do, well, no. If it's effective, I like doing that. But if it's not effective, I don't like wasting my time. Put it that way. All right. Any questions from you before we get going into the semantics and syntax of lists? Okay. And like Ranjani, like you said, the tuples, if that's a topic that you're interested in, let me know on either, like I said, we can do a pop-up, or I can just do a couple of demos and stuff and kick them to an individual group or I'll probably kick it, if anybody stays on, I'll just kick it to the whole group. And you can just say, oh, that's another one from Kirkwood. I can put it in my spam box. And so.
Don't worry, Don. I plan to be really demanding in the fall.
Oh, you're going to wait till the fall? This is scaring me, Johnny, because I haven't already. It's been. I love it. No, I think it's great. I've never had anybody though said, give me homework in the middle. I thought that was fantastic. I thought it was great. My wife thought it was really effective. So she's going to start using that tool on her own. I'm not sure I appreciate that part of it, but that's okay. Okay. So I guess what I really want to stress with lists is that joking aside, like we talked about at the beginning, you guys jumping into this pool without knowing whether there's water there. That's exactly what we do with kids, with lists. That's what almost all textbooks, and if you're a college student, since they just impart information to us, that's the way it is. I don't know about you. I can remember doing we had a special pre-med program. I can remember that's when I was going to do that. We had a experimental structure, and so there was like 6 of us that were just thrown into this second year calc our freshman year, did a whole bunch of stuff, and the professor would just spew an insane amount of stuff, but we would always get together as a group and sit down and figure all this stuff out, basically teach ourselves what was going on to help each other and do it. So but that doesn't, we don't want our high school students to have to do that, or middle school students. If they have to do that, then they don't get to the juice, the fun of it quickly enough for most of them with their level of maturity, and therefore they fade away. And the more diversity you have, especially if it's language issues, the more issues you have that are on top of this pile, whether it's socioeconomic or language or whatever, then the quicker it is, the easier it is to fall off that pile. And those are the ones that we really want and or need in our culture and in our classrooms and everywhere else to do this. So teaching lists or arrays in a way that makes sense, that gives them algorithms so that they can attack this stuff with confidence, I think is really insanely important. And textbooks really suck bad at that. And so that's what I want to do. And in that situation, we need to make sure that we organize in a way. So what I do is what's worked for me. If you come up with other ideas, or you think one of them is really pitiful, or you have an approval, please, please, please give that out. I think that's exactly what's going to be going on, and we need to do that. All right. So the algorithms we came up with, first of all, we backtrack a little bit. So the first thing is when I read a problem, and this is part of the way we teach and test and everything else, when I give a problem, where the first thing is going to be is, if you got to pick 3 out of 5 codes to write on my test, a couple of those codes are not going to need arrays or lists. And if you solve them with a list, you lose points. And if you try to solve a problem that doesn't need a list or needs a list without a list, you're not going to be able to do it very well. So what was, when I read a problem again to review, what was it that said, aha, this sucker needs a list? I know that. That's the tool I need to pick out.
Unwieldy number of items. Oh, can you hear me?
Yep.
Oh, good. An unwieldy number of items that you have to access multiple times.
Perfect. I like, once again, I always tell the kids, don't use my verbiage unless it works for you. It's better to use your own. And that's what I like in that way. It's the best way to hear that. And that's a good way to set that up. All right, everybody got that in your own jargon, whatever it is? Okay, so now that we have that, we know I need to pick up this array. We don't want to have to reinvent the wheel every time. And some people really struggle. It was interesting. I have a good friend. She passed, but she was a phenomenal math teacher, and she hated the use of algorithms. And so she and I would have these big conversations about it. And my point to her, and I think both points were valid, but my point to her was that if she didn't think memorizing an algorithm, like she was a math teacher, so like solving linear equations, you do these 4 steps, it always works. She just said, that doesn't work. You need to understand what's going on. I said, yeah, but if I'm doing a foreign language, there's nothing wrong with going through memorization before we get to understanding. If you can jump right to understanding with something, fantastic. It's just like writing a code. If you don't need to do an outline or pseudocode because you see the answer, you understand this problem that clear, fantastic, that's cool. But when you run into a problem where you can't solve it straight off. You better have some techniques to attack this first to get yourself to the stage of solving it. And to me, that's what algorithms are. If I have an algorithm, if I need to memorize that at the beginning, cool. Hopefully I'm going to do enough of it so that I don't go, all right, I now do step 1 and now I'm doing step 2. But you may have to do that on the interim, and that's not bad, right? So the algorithms we have, we separated the list problems of the 3 categories: a general, a tally, and then a Boolean, either way you pronounce it, whatever you want to. And if you have my notes, you have 2 things I kicked to you guys on the interview. One was the outline, which is kind of what we're following here, and 2 is the codes. I put 3 codes, and then we may get to the 4th one, I hope. We'll see what's going on, and we'll talk about them in the sequence. I'm not going to do the codes or this in this sequence because I think the tally array is one we were finished with last week, and I want to go back and review and summarize that. So when we did this, and if you can do it without looking at the notes, all tally arrays. Now, what type of things were examples of tally arrays, Gunnar? Because once again, that term may or may not be what you want to call it with your students, or is that may not be what you feel comfortable with, or you know your student body and that wouldn't work. But what type of problems were tallying problems?
Accounting votes for an election.
There we go. The election, timely things that we've got going here. Yeah.
What about keeping track of participant information or counting up participants for specific sessions in a conference?
Yeah, their conference workshop. How many bodies? We did that exactly for this one. You know, how many bodies we need to have? At least 5 bodies to make a workshop go. Therefore, how are we going to do that and make sure it happens? Okay, so that would be a tally. Perfect.
Inventory or sales.
Yeah, inventory or sales is a big one. And it was interesting when I first started teaching in Salem Kaiser, there was another teacher at another high school who was very bright, way more intelligent than I was. But the fact he really struggled because at North we were growing and it was happening. It was really kind of cool. And at his school it wasn't happening, and he couldn't figure out why. And I said, well, you know, there's a whole lot of different possibilities, and some of them may not have anything to do with you at all. But can you just kind of tell me what you do? How do you start your year off and what goes on? And he said, well, we spend the first 3 weeks and I teach them the history of computer science, and we do binary and octal and hexadecimal translations, and we do all that. So I thought, for the first 3 weeks of the course, you take one of the most interesting, fascinating, challenging courses and make it kind of into a boring history class. And there's good history classes, but this way, the way I looked at his worksheet, and I went, so the kids are memorizing, they want to come in and play with a computer, and they're memorizing how to translate from binary to hex. And you were going all through that. Now, by the way, that was standard approach for many textbooks. And he said, but Don, you know, I want that. These are cool things. I said, yeah, but if you interject them at one place at a time, it's astonishing how they could fit with a problem. You can teach binary and hexadecimal when you're ready to do that in code. That's a really cool for-loop translation problem to do that. And then it becomes not only you're doing that, but you're combining it with syntax. And the reason I'm doing this inventory right now, especially with what's going on in the world, pandemic and all that stuff, just on time delivery, you may or may not know the history of that relative to tally arrays and what we do. And Japan killed us in the United States with automobile production because they did just on time delivery right after World War II. And it was crazy how they could ship a car from Japan, make it better quality, cheaper, and everything else, and kill off all our auto industry in the United States because of this concept. And tally arrays are a great way to demo that and bring that history into play at the same time. It's kind of cool. Kids get into it that way. At least I found it. So yes, an inventory program. And by the way, where do we see inventory programs? Almost every day. Probably the students see it all the time, once again relating to them. It's cool. When your inventory programs accessed every single day almost by our student body. You may not have thought of this. Yeah, that's, you see what I mean? This is what we don't do as teachers enough, right? We need to hook them into stuff. And this is what's kind of cool about it.
Attendance?
Okay, yep, and actually attendance could be the same thing, just like the workshop thing, but an inventory thing. If you go to a grocery store, what happens even to the 7-Elevens now, anywhere? An item, you scan it, correct? What's going on when they're scanning that, actually? When you think about it, a whole mess of things are happening that human beings aren't involved with, that they used to be involved with. They used to pay family living wage jobs to do these things. Instead of 10 people, we now have one person who's paid bigger salaries to do the software and everything else and maintain it. All right, because when you scan it, it takes an ID number, subtracts it, adds it to the thing, it does all this stuff, and then when you get less than 10 boxes of Captain Crunch, your store automatically calls the warehouse and orders more Captain Crunch to be delivered to your store tomorrow. And that's what's going on. And that's all done by an inventory program. So you can see all the site extensions. We had talked about that. Students are really pushing this stuff. Guess what we can do? They can push it out to the side. We can do a core basic one with most of the students, but for the A-level problem, they can push it out and say, show me a list of items that need to be reordered at the end of the day. That's just using an inventory one based on some other conditions, right? Does everybody see that?
But your question was, what kind of inventory are students concerned with? Is that correct?
No, that they deal with every day. And
I have no clue. I don't feel like kids care how much groceries there are in the home. They don't care about anything. They just kind of go through life and whatever. Things just pop up.
But when they go to buy their hamburger or their candy bar or their can of pop, they don't want to have to get charged an extra 5-10 cents for that. And well, just a bit. I know what you mean. But the fact is, at least it relates to what they're doing in their daily life. Just going into McDonald's. Heaven forbid they actually eat at McDonald's.
So you mean that as consumers, they're associated with inventories, but not not in their personal lives. Okay.
Yeah, correct. Well, and attendance deals with that and all that other. I guess it's that these things impact them in ways that they never thought about before, and that's what. If they work in the canneries, I know that I did. And my student population at North, huge number of their parents, and they did during the summertime. Therefore, everything in the cannery is dealt by inventory, and you can start talking about that.
So something that popped into my head on Facebook, there used to be just a single like button, but now there's 5 different options that people can pick, and so that would be an array, a tally array, that just slips into one of those 5 categories.
Yep, exactly. And then you could do something with that relative to the number of them. If this happens, and then you get paid this much per, or whatever the case may be, right? That's that kind of an idea, exactly. So I think there's a lot of options, but I just want them to see that they relate, that there's something there that is relative to them in their daily life. There we go. And probably Facebook is better than, or whatever. I'm sorry, I don't want to waste my time too much on that. So yes, I'm the old guy here about doing Snapchats and airheaded tweets and other stuff. So anyway, yeah. So I could, we won't go even that far. All right, so here we go. So the fact is that with these things, and there's one more mathematically, like I said, this is the one that students really don't put into this category, but it is.
Could you please repeat that question when you, without the pronoun, the it, what is it?
Oh, someone's being snarky here. This is great. I love it.
No, I wasn't being snarky. I really don't know.
Oh, no, I love it. Well, that's 100% valid, because I should not use pronouns in my sentences.
He did that to us in school all the time.
That's what I'm talking about doing. My students would kick it back. As soon as I would say that to a student, guess what my next sentence would contain? And they would nail me immediately. So it was always poetic justice there constantly. So no, in mathematics, there is a process that the kids have to know for all their standardized test crap that they have to take. And it is a tally array. And they don't think of it that way at all, which is really kind of a shame, because it becomes very easy. This is what's cool. I could teach freshmen this concept and coding. And then when they get to the math class, all of a sudden, this is real easy for them because they've already done it. They understand it completely. I love that when they become the top echelon of something they didn't think they were very good at because they've had previous experience. I think it's fantastic. So once again, what is the mathematical process that actually is a tally array?
Matrices?
Matrices could be, that's double dimension stuff, but we're not there yet. It's easier than that.
Linear equations where they draw their tables for functions.
You could actually do that if you kept the values and needed to keep the values.
Well, I mean, the x's could be the indices
yep.
and the y's, yeah.
Yep. That's a really good one because you use, you can use 0, 1, 2, 3, and 4 for your x values, and then the y coordinate would be the content, correct? But there was something else. Actually, I think we talked about this the other day, but we talked about 1 or 2 or 95 things last week. And you don't pay attention to me anyway. You're chatting back and forth. I understand that. That's okay. It's the mode function. We talked about that. The mode is actually 100% the same as an election. 100%. But students don't make that connection at all either. They don't ever. It's funny because I usually teach all this stuff and then I'll put the mode on the test. And it's insane how few visits, I say, here's 5 problems, pick out 3. Well, the mode was 100% copy of what we did in class multiple times, but it was the least chosen problem ever on every exam I gave it, because if we hadn't discussed it, they didn't make that linkage, or they solved it in the weirdest, hardest ways. It was insane. I love that. All right. And then, so we have general ones. We'll go over like a bank account problem we've got. We have Boolean array, tally arrays, excuse me. We'll talk about them real fully. And then we have Boolean arrays, which we'll get into similar to this. Now, the tally arrays, where we did this, and it's on the board. This is the algorithm that I think is really good. Are you seeing? No, it didn't go there. Keep trying to kick that to the other camera.
I tend to call these tally problems popularity contests.
Ah, there we go. I like that. It's not kicking to my other. I may have to do it the other way. Here we go, guys. I love tech problems that work one way a whole bunch of times. Oh, now it finally did it just at the last minute. Here we go. Where this was, and notice what I have done on this. And are you guys seeing it? I know we have some sun spots here. I know that. But is everybody seeing this concept? This is the algorithm that I think is insanely important for them to get this rhythm. And notice we developed.
Could you zoom out a little bit, Don? We can't see the top.
I think it's
all
a
it
knit.
says is tally. All it says is tally up there. Oh, I'll move it up there a little bit and we'll do it down. I could zoom out, but then it's too small. Okay.
We couldn't see a knit, so now we can see a knit.
Pardon?
We couldn't see the number 1 item. We
Okay,
couldn't see.
now we can see it and I'll slide down. I'll do it that way rather than zooming out just for space. Let me see, this right this way. Okay, so remember we developed this, so it's not like something that we just slap in their face and say, memorize this sucker. We went through it and discussed it and did it with a couple examples would be good with the students. But then what we do is we want them to see real rhythm. I call it a rhythm to a problem. Once you've got that, it starts making sense. And there was 3 key pieces of this. And now, are you seeing one still? Nope. Yep, we may have to back up. Okay.
It's good now. We
You
got
okay?
1, 2, and 3. We've got
All right,
init,
good.
run, and use.
All right, so that's what we need to say. We need to initialize the process when we went through all that and talking about why. And by the way, some languages you have to and other languages don't. And some of you only have to partially do that, but that's not what we want to do. We want to understand the process. We want this to be as language independent as possible. So initialize, run, and then use, correct? And then why was the initialization and the use both for loops?
Because we know what the exit is.
Because,
There are no conditions to be met to initialize or to use, right?
because,
It's a finite loop.
but why?
We know how many we have.
There we go. We know how many, we already have to know how many candidates we have running in this election, or how many students we have, because if I'm doing attendance, I have to have that already built in. So both of those, I know initialization and use, I'm going to use them all, and I'm going to initialize every one, and I know how many there are in the beginning, in general. All right, there's always exceptions to the rule, but that's what we've got. So if they know that concept, they immediately don't have to start reading the problem and going, oh my gosh, what do I type a loop? No, nope, nope. I have to initialize, it's a for loop. I have to use it, it's going to be a for loop. Do you see the benefit of this? Later on, yes, it's better to get past this and understand it without memorization. But in reality, it's okay to go through this step. And then the middle loop was running the process, which meant we're running our store during the day. We're finding out our customers coming in and out. We're doing an election with voters coming in and out. We're doing anything we're doing, the mode, we have test scores coming in and out that I'm going to, now by the way, notice we have a known number of possibilities for scores because we know it's going to go from 0 to 100 if it's percentages, right? So, but I do not know how many tests necessarily were taken. Those are two different issues, right? That's why the initialization and using them, we're using the scores. And that's what the important part is. And it's in the orange here, which is this. This is one of the key things that it's insane how many times the students will blow this, especially on a big exam. That's why I'm saying having this memorized, okay. If you can do it by understanding it, not screwing up, that's even better. All right, let me see. I think if I move that down a little bit, are we still seeing, now we're seeing all three?
Not yet.
No. Thought I had that all figured out, and I don't. Okay, well, tough. That's the way it goes instead of around. There we go.
We need to see the bottom a little more.
Yeah, because I got tally. I don't want to see tally there. Oh, it's good enough. High tech, I love it. It's all great. Now we don't have the first one, but that's who cares. You got them down. You have it on your list. It's crazy. It's in your notes. So, but what I want to try to get across is, oddly enough, for memorization, this pause, that was a key thing because that pause is the most common mistake students make when they're befuddled and in the middle of stuff. Okay, where did that pause come from? And you may not want to use pause. It's what I did for this at this moment in time. What do I mean by position? Go by the, and
Index?
there we go, the index or the address, depending on what you want, right? And remember, what did we say is the first step you should do? Before you start a tally, a program, or anything else, what's the very first thing, any list problem, matter of fact, what is the very first thing that would make it the easiest step that makes things easier for us? And most students don't do it. What's the
Yes.
easiest thing to do to make any list problem or array problem easier? Yeah, Judson.
I was just going to ask if you'd rephrase the question.
Okay. If I read a problem, any problem I read, and I now know it's a list problem, what is one of the first things that would make the whole writing of code cleaner and easier for you, less possible stupid mistakes, and yet very, 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 very few people ever do it?
Ask for an upper bound.
Okay.
I mean, that's just a Python thing, right?
Yeah, yeah. No, so I'm talking about generically, and maybe instead of taking a whole bunch of time, we'll kind of do it. And we talked about this before. One of the key things is draw and label your picture, your chart. Draw and label that chart, because what will end up happening is if you draw and label that chart, what does that do for me? What kind of things does that help me do, both semantically as well as syntactically?
It does help you provide, like identify good naming conventions to use for your array.
Okay. And how do we know they're good? Judson? I mean, what's a definition of good in this case?
So the example of the popularity contest, the votes, you would identify that the array is holding votes, so you'd put votes at the top, and what those votes represent, the candidates on the left side and the votes of the candidate. So it just more easily helps you understand what good names to use and what the array represents.
I like both those pieces of that puzzle, right? And there's actually a third part that really fits in well, is what you just said, votes of the candidates. When we write the syntax, if we write it, it will come out that way, because students will write candidate of votes, candidate sub votes all the time. And it makes no sense, but in their brain, we're keeping track of the votes. And so therefore, since they never labeled the picture, it gets mixed up all the time. There was probably more wrong answers on AP tests, especially the A-level tests, because of array of variable mix-ups than there were because of any other reason whatsoever. And they would lose huge points. And it was just insane. I kept going, oh, you poor kid, you did all this work, and out of 9 points on this AP question, you're getting 2 because you screwed up every one of these. And I can't give you any, I know you know it, but I can't give you any points for this stuff. So labeling it and drawing it and labeling it clarifies your understanding. It clarifies the good choices of variables, which make things easier. And then it also hands us our syntax. But if we don't tell them that and reinforce it by telling every student, I want you to help with this class. You guys will be the same way. My Lord, I had 35, 40 students. I didn't have 30 students that canceled the stupid class. And I had multiple levels. Judson, I can't remember in your time period whether I was teaching 2 or 3 levels of coding in the same period. Probably, because it was almost always what we did. So my time was insanely valuable. And therefore, it was great for them to help each other. But I always wanted to reinforce, you're not helping your friend by giving them the answer. You got to set them up for them to figure out what the answer is. So if they come to you and say, no, please draw your picture and label it so I know what you're talking about. And frequently, I always love it when you ask, do something, and then all of a sudden there's no question. That's the perfect question. Is that when you do what you need to do, all of a sudden the question's gone. That means there is an approach. But if I hand it to you or your friends hand it to you, in the middle of the test, there ain't going to be anybody handing it to you. So that takes care of copying and also takes care of getting help, because if you give them a little quiz, that takes care of both pieces right off the top. All right. So for the algorithm, we have init, run, use. We have for, while, for, controlled by all the variables, controlled by the index or the position. And then internally, we do the same thing. To init, we set them to 0 or set them to some beginning value. Run the process. We have that tally, because that's what it is. That's hence the name of the thing. Info sub pos equals info sub pos plus 1. There we go. Or plus count, or plus or minus count. If it is, they can subtract from the inventory, whatever the case may be. And then use for loop, because we know we're going to go through the entire array, which is a constant size. And then at the end, we're going to run this sucker and either do an if to say, if this situation occurs, do this. So like reordering, if the number is less than 5, reorder the name of this beast. All right, put them on the list, or tally them all up, tell me, or find the winner, right? So frequently we have an if-then stuck inside of the use. All right. Now, if you think about that, that now means all tally arrays become the easiest code on the test, because they have the exact same consistent pattern. When I first started teaching this, as I alluded before I taught, no one chose tally. It was the fewest, the least frequently chosen problem out of the 5 that I would give them as choice. Once I taught this algorithm, it was the most common problem. They would look for tallies. I would not put 2 of them in the options because I know they would pick those 2 and it'd be the same thing. And I kind of wanted to force them to do other things. What a nice problem to have, that the hardest problem became the most frequently used, just because I decided to teach it correctly. What a nice idea. Not that they tried to learn any harder or better or focused more. I just finally figured out how to teach it for me better. All right. Now, we have an option. We can now go through one of two things. The general and tally, we've got that. We can actually look at syntax and go through those pieces of the puzzle, which might be advantageous. Or we can talk through the algorithm of the Boolean array, which is a little quirkier, but really kind of fun. But it just depends what you want to do. So as a group, do you want to dive into syntax? Since we haven't done syntax with lists at all yet, hardly, we can do that, or we can go continue with algorithm discussion. Where are we? So if you want to do syntax code, do thumbs up. If not, keep them down and I do it. So those of you not showing your face, you don't get a vote. So that's where it goes. Or you could pop the little thumb. I guess you could do that. Yeah, technical. So I'm getting one syntax. This is like American democracy. I always love that. We have one person voting out of 35. So that's slightly better than American democracy. Oh, now we have two. Okay. Okay.
Wait, I thought you said vote if you want syntax. So those of us
Oh, that's
not
true.
voting don't
My
want syntax.
fault. You're right. Oh, you're exact. So I guess there was 2 for syntax and everybody else is saying algorithm. Oh, wait. Oh, that's a way to do an election. Have the one that you want to be the one that's by default. Oh, I like that.
I'm fine with either, Don. I just want to somehow get this really fixed in my head, and it's not right now.
Yep. And we'll have time. Fortunately, since it's the time we have, I think we'll have time to get to the syntax too. So we'll get to that then. Okay. I'm going to throw the discussion of this because some of you who are more advanced, and there was a couple people, the Boolean arrays will be something you can mess with while the rest of us are going back and talking about syntax. So this would be good to have this discussion on Boolean arrays first, Boolean lists, and then come back. Okay. So Boolean or Boolean stands for
A return value of true or false.
so yeah, we have a
A
true or false.
binary.
Yep. 0 or 1, yes, no. So there's only 2 possible responses that we have. Okay. Well, what's interesting, you can make, there's a pattern for Boolean arrays, Boolean lists. But fortunately and unfortunately, depending on your perspective, it is nowhere near as tight as the tally arrays. Tally arrays are like, this is it. I don't care any of those examples you did, which is cool. You guys came up with a couple I have not heard in our discussions before, which I love. But every single one of them works identical. In a way that's nice. To me, it's not as fun, but it's nice. If I'm a student taking a stupid test, I really like that concept. That if I know that algorithm, I don't have to think hardly at all. I can get through this question and spend more time thinking on the next question. That's the way it works. Boolean arrays have a pattern, but they're nowhere near as tight. So to do that, what I'm going to do is I'm going to bring up 2 kind of examples that are at a higher level. They're more interesting. And then you can either play with those or, and one of them we've got coded, the other one I don't. Or I haven't given it to you guys. And we'll come back and talk through this, and we may choose one of these to do your syntax. At the end of this conversation, the good thing about doing this one, we can say, now, which of these 3, general, tally, or Boolean, do you want to be the one that we introduce syntax with? And therefore, we spend more time solving that problem, as well as teaching the syntax of that problem. So it's kind of nice, all right? So here's 2 Boolean arrays, and tell me why they are Boolean arrays. The first one, I want to start with a precursor problem that I would have introduced back in constructs. When we did constructs, I would have given this problem someplace. And matter of fact, if I remember the problem set, you know, that big honking 12-page thing or whatever that I gave you, I think both of these problems are in there. One of them is, the simplest version is, let the user input a number and tell me whether that number is prime or not. Okay, so what would I do? Going back to that thought process, how would I solve that problem? Tell me whether this number is prime or not.
Well, you need to figure out if it's divisible by anything
Okay.
without a remainder.
Perfect. And that's what we call hands-on. That is that I have to know what the definition, and I could have to practice that just like math. I told you, in order for me to tell the stupid computer how to do something, I've got to know how to do it really well. In order, the computer is a perfect student. It demands that the teacher can do the job well. That's not necessarily what all teachers fit, professors especially, fit into that category. They're brilliant, but they may not have any idea of how to teach anything. They impart information, and sometimes not in a very organized way.
I recommend that we try to identify what we can iterate in this process.
Oh, okay. And so what are you talking about? So what do you mean by iterate?
So, okay, if you want to check if something is a prime or not, well, the first thing you want to do is check if it's divisible. Well, you want to go through all the numbers below it, but you could do a quick check of whether it's even or not. And then if it's not even, then you can just check the odds or something like that. Like try to shorten the process somehow, and not check every single number that comes right before it.
Okay. As a matter of fact, if you think about it, what you just said, what I like is that students sometimes will sit there and do that, and they will say, oh, 2, and then the next is 3, and then I don't need to, I'll go 5 and 7, and then they'll give me a list, because my example was like 91. Tell me if 91 is prime. So they'll sit and make literally a list of all the numbers between 2 and up to someplace, I'm not going to give this answer away, up to 91 that were prime, and check to see if they're divisible into it. So then guess what Kirkwood will do? Kirkwood will give them some number like 327 and say, now do it. And because they, oh, that's not fair, Kirkwood, I have to get it. I go, that's but I did 5,801. Tell me if that's prime. Oh, but I have to check. I go, no. Then that means your algorithm wasn't cool. It wasn't efficient. So exactly right. So what numbers do I need to check? We start with 2. Now, why did you say even and just check that first?
Well, certainly if it's not 2 and it's even, then it's not going to be prime.
But there's another good, that's 100% right. But in all honesty, think about it, there's another good reason to start at the bottom, because some of the kids, when we brainstorm this, frequently, what we're just doing now is perfect. And some of you may be doing that who are blanked out. You may be doing this and you may do it. That's 100% appropriate too. I will give that prompt and say, go. And once again, if you want to stay here and sit and discuss things up front, you may do so. And since this is the beginning of the year, you know your students. I bet you could guess almost to a name, if you've had them in the past, who is going to be back on the computer before you even close your mouth on the problem set, much less do you want to stay up here and discuss this. But gradually, I love it, because we actually sometimes have prizes relative to speed, and we'll talk about that when we get to Civ. We'll talk about how that works. So what is the benefit of starting with 2? Not only is it, or no, I'm not going to give anything away. What would be smart about starting with 2?
Half of the factors or potential factors are even.
Perfect, because as soon as the sucker is divisible by a number, what do we know?
It's not prime.
It's not prime. So doing 2 throws away half the numbers. And now this is a hint, this should be a big hint relative to constructs. Soon as it's divisible by 2, then it's not prime. I don't need to go anymore. And since half of them are going to be thrown away, that's really nice. Okay. And then what would I do if 2 doesn't go into it?
Well, then you need to start seeing if some odd numbers are divisible with it.
Okay. Like some, let's be a little bit more precise than that.
3.
3. So we check 3. Cool. And then what?
5.
Oh, good. Now, you could do that, but you did something in your head to make that happen, because you went from 3 to 5, right, in your head, because we're smarter than the computer.
Well, 4 is divisible by 2.
So if we were making the computer do this, we would stop and we would go to 4, but then we would say, oh, that's divisible by 2 already, so I don't need to do that.
No, we would start with 3. We'd give the computer the 3, and then we'd say just keep incrementing by 2.
Oh, interesting algorithm. Do you see what we're doing here? Because if I did that, now what's the benefit about those 2 different differentiations? the first one, if I had to check to see if it was even every time, every time I did this, I would have to do a check to see. So that takes time. Whereas the second algorithm is interesting because once I got to 3 and I just started with 3 and added 2, incremented by 2 every time, I wouldn't have to do any mathematical calculations. It would be there, right?
So I want to do this like the sieve and
No, we're not to sieve yet. Remember, careful, don't give anything away. We're talking about just solving the simple, I want to know if a number is prime. Sorry, Debbie, I didn't mean to cut you off, but I really do want to cut you off because I don't want to give any of the intellectual leap away. All right, you see what I mean? Sorry. So, does this make sense? So we would go 2, then we go 3, but hold it. If I do 3, taking your same logic there, Johnny, when I got to 9, I really shouldn't check 9 because it's already been divisible by 3. So should I now start doing some other checks along the way? This 15, I don't want to check. I really
Right,
don't.
so some way to check the odd against the odd number and all multiples of the odd number.
Okay. Now, we could do all what you're talking about, right? But what's the deficit of doing that for solving it for one number prime? What would, you're thinking, and we could do that as a human fairly well. But in order to have the computer replicate what we're doing, what would we have to be doing all along the way? Especially if it was something that was divisible by like 19 and 23, right? We had some non-prime that's way in the heck gone out there, right? We would have to be doing all these checks constantly, which the checks themselves would be taking up a radical amount of time.
Could you do it based on what the last digit of the number that you're dividing? Is there a shortcut? Because obviously, if it's even, you don't need to do it.
No.
If it's a 1, 3, 5, or 7, there's probably different rules.
And we could incorporate those rules. And I like kids learning, divisibility by 3, divisibility. We like those tricks. Those are handy. But once again, if we did those, and you guys are getting really intense here. Most classrooms are not going to get to this stage, which is cool. You may have a classroom that does that, which is fantastic. But you need to say, what would the deficits be of that solution? And I would have to check what you're talking about with every number, and every check in a loop takes time.
I like Catherine's idea, but the only impediment is I'm always shocked at how little of divisibility tests kids actually know. They think I've done magic on them when I give them a divisibility test.
That's because those calculators just don't have that stuff built into the screen. I don't understand that. It's easier just to do this. I think the next 2 generations down, they'll just be born with a calculator in their palm. I think that'll be the next development that'll happen is, we don't need to think, we just use this. So here we go.
I think that we have a lot of requirements. I think about 3, if you have any number and you add the digit and the sum can be divided by 3, it's okay. Else it's a prime number. I mean, any number.
Yep.
Let's say 127. 1 plus 2, 3 plus 7, 10. So this cannot be divided by 3. Also about 5, if a number ends in 0 or 5, can be divided by 5. I think.
And so those number rules, what's cool about those, Nikos, and I like that, the only problem comes out with computer science, and by the way, there's a sort that is phenomenal this way called the radix sort. And intellectually, we as humans can do some stuff that are unbelievable relative to that. But then when you do them in a computer program, it's insanely slow. And the reason is, in order to do what you just said, Nikos, which is exactly what we teach them, right? That which Johnny is complaining about our kids not knowing, those are those rules. But to have the computer separate a number, 127, into 1, 2, and 7 takes a lot of code and a huge amount of time, relatively speaking. Therefore, the savings of time relative to divisibility is eaten up, and more so eaten up by parsing that number into 3 pieces and adding them together. And it's an interesting problem if we had time or and in our pop-ups, if you guys wanted to deal with sorts sometime, phenomenal, interesting discussion. And the radix sort does exactly that if you choose the wrong contents, because we have to parse them, and the act of parsing takes up so much time that this insanely fast sort is all of a sudden the slowest sort there is, because the parsing takes up so much time.
I think before you find a solution to this problem, you kind of need to know, are you trying to do this for all prime numbers through umpteen billion, or are you just trying to do it for lower numbers because the computer is so fast that you can check every possible factor up to the worst case, which I'm not going to give it away because you're probably leading up to that. But when we're solving problems like this, the things that work for humans actually slow the process down because of all the checks that have to happen.
And that's an important conversation when you're in the middle of this stuff and early problems. That's a great conversation to have with kids right there.
I agree about this. But you must know the requirements, because if you don't know the requirements, you can't set the program. I mean, you can't have a program if you don't know what inputs or what what rules you have to plug in.
Well, in this case, I just say input any integer and output whether it's prime or not. Well, I'll say even any whole number. Here we go.
I was thinking about modulo or something like that. I mean, about the division, and after the division, if you see, I mean, if it's, I don't know. I really don't know. I really don't know.
Well, what's there's no problem with this discussion. As a matter of fact, with good students, good classes, you're going to have all of this. And so there's nothing wrong with what we're doing here. The only thing is we take each one of them. And by the way, in order for us to do this, here's the hard part. And this is where old age and experience kind of comes in. You have to have to do these things or looked at the codes and to know kind of the issues relative to these beasts. Or as we all know, when we're new at this stuff, you're flying by the seat of your pants. And when you're finished this class, you're mentally exhausted because you're thinking 5 times as hard as the kids are to be able to answer their statements, to be able to take their ideas and say, or you say, cool, go, try it. You got it? Try those and see what happens. We'll come back together and discuss these options and see which one's better and why. So there's nothing wrong with any of those approaches. I want to back this down because I want to get to the Boolean array here a little bit. So I want to back it down and say, all those checks, as Tim was alluding to, take time. And therefore, I'm telling you up front, and we wouldn't do this with kids, I would say, go try that. And come back with your code, and you won't get graded down with it. Let's just find out what happens, right? I'm just telling you, give me a number, tell me whether it's prime or not. That's the problem. So if yours works, cool. But we will compare it to the other ones to see what goes on. So do it, fantastic, go for it. But if we're in this discussion here, we got to say, they ask me, I'll say, the checks take more time. I like the way you said that, Tim. The way the human brain works, it takes longer for the computer to do most of those approaches because the computer is real fast otherwise. That's a good way of putting it. So in this case, I would say we're going to start with 2. I like Ranjani's idea of going to 3 next and then jumping by 2s because that doesn't take any computer time. There's no conditions, there's no checks. I like that one. That's a good variation. So if I'm doing, like I said, 3,119, so I would go 1 and 3, and then, 2, and then 3, and then 5, and check. And am I going to have to go all the way up to, let's say it is prime. Do I have to go all the way up to that number to check out? I can't even remember what number I gave you a second ago, but whatever. Do I have to go all the way up to that number to check the visibility to find out if it's prime or not?
You don't have to.
Oh, well, what? No, how? Well, the question comes up to be is, if I don't have to, where do I have to go and why? Without conditions, without checking things, right? I don't want to check things because that slows things down. How far do I have to go with a number? And you don't need, let's pick some simple number, simpler number, like 87. How far do I have to go with 87 before I know it's prime, if it is? It doesn't happen to me, but that's okay. So I check 2, I check 3, neither one of them go. I check 5, I keep going, right? 5, 7, 9. Do I need to go up if I have it like 91? 91 is prime, right? So therefore, do I have to go all the way up to, I think a 91 is prime, isn't it? Yeah. So therefore, I have to keep going. Do I have to go all the way up to 91 before I say, the suckers, it's prime? And if you're shaking your head no, you have to explain why. So you can't shake your head no. This is like a real political conversation.
Why don't we talk through it? Why don't we
Okay.
talk through it? So if you're giving me an odd number to begin with, I know that the number right before it is not going to work because that's going to be even.
Okay, so we can stop at num minus 1. Everybody get that? That's kind of cool. There's a good checking point. So let's pick an easier number, right? Let's pick 37 so we don't have to go as far.
Would
So
you,
37, the highest I need to go for so far has been 35, right? I don't
So-
need to check 36.
I'm thinking that maybe only halfway, like the number divided by 2.
Why?
Well, because if it's not prime, there's got to be 2 factors. And so if you find the lowest factor, you don't have to check the higher factor. You already know it's not prime.
I like that. There's pairs, prime numbers. When you do it, if you write out the chart, right, that's what I'm talking about hands-on. You write out the chart, you get 2 and 37, 2 and 19, 2 and 19 and a half. Go 37, 2 and 18 and a half. That doesn't work. 3 and so you have pairs, and you see that those pairs kind of come together. And when they come together, they start crossing over. So I don't need to check the second half of them. Cool. So right now it looks like I only have to go from 2 and then 3 up to half the number, right? The integer part of half the number. Now that kind of makes sense. So
But
is
it's
it
not going to be
floating?
half. It's not going to be half the number, because if it's half the number, then it's even.
Oh, the integer half of the number. Okay, we throw away the decimal. You're exactly right. 3 to less than or equal to half the number, and we only take integer parts. Okay?
But
So
you don't need to go that high.
What's that?
I'm with
You don't
10.
need to go that high.
Oh, so what does that mean? What are you talking about?
Well, let's say you take the number, let's say 100. You know that 20 goes into 100, but because 20 goes into 100, there's actually another factor, and that other factor is going to be smaller than 20. So what you find out is that the pairs converge towards a specific point. And in the case of 10, you have 5 and 20, and you have 10 and 10.
So we're going to start guessing again?
So 10 is the square root of 100.
Well, now you really took a big leap up there. I like this. So when we end up deciding, we're going to go to half the number, but it's even more than that or less than that. In all honesty, what Tim just said is kind of cool, and most students aren't going to see it, but you can play the game and discover that the largest one I need to go up to would be the square root of the number. Because the pairs converge, good, and then they cross over. If you do that, that's what happens. So take 36. The highest I need to go for 36 is 6, because beyond that, the pairs have already been touched on the other side, and so they're covered. Good. So now we got this. I'm verbalizing your guys' algorithm. So we're going we do 2 first. We check that. Cool. Then we go from 3 up to the square root of the number. I know that range. Therefore, it's going to be a for loop. Make sense? Good.
But isn't it going to change?
You even write the code.
It's going to change based on the number.
Cat smiles up front. Okay. Yeah.
But it is going to change based on the number. So yeah, it can be a for loop if you're using the square root.
That's what I'm saying. Yeah. So the square root. Yeah. So with 36, and by the way, yes, Tim, this is so fast it doesn't matter, but I don't care. I want to get the best, even if the speed wouldn't make any difference. So for 36, I would check 3 through 6 to find out. Well, no, 36, we have that. Let's go 49, right? The 7, so we've got that one. Or something like that. I was just trying to pick up an odd one that it would do this before this stage. I'm trying to pick another one that, 39. There we go, 39. Oh no, but 39 is 3. So I'm trying to tweak your answer here a bit. So I'm going to go 55. So 55, I need to go up to the square root of 55, which is 7 or 8, or 8, 7 in there, right? So I need to go up to 7. I need to check 7 to find out if 55 is prime.
Can I interrupt and say that there needs to be a tiny number theory lesson before all this happens for kids?
Although we can learn the number theory as we're discussing this with the kids.
Well, I mean, what I mean is like we have to ask these questions in some form or another to prepare them to write this algorithm. Yep. Because that square root thing would probably not, it has to be discovered.
Yep. And that's why I 100% agree. That's why I say we write the charts, and we do that a bunch of times. And that first cartoon I showed you, where the sheep need a sheepdog, you and I are the sheepdogs. That's reality. We have to know where we want to go. So therefore, we have to put things in the way for them to get to the right response. You're exactly right. And building that chart shows you the crossover, and we have to do it a bunch, and they go, okay. We're getting this one deeper than we want, but actually I'm okay with this because it's going to lead to the other conversation being easier because we've hit a lot of the responses already. But in reality, I'm saying it doesn't need to be a for loop. I'm saying the best answer is not a for loop.
Is it a natural flag?
No.
Are you talking about recursion?
No. I'm talking about, oh, no, you're not. I would never be, well, that would be kind of fun, but I would never be that evil to throw out something that we haven't discussed yet. And remember, no. Although that would be kind of, with you guys, that'd be kind of appropriate, but that's not the same. Okay. And the reason is you may not even need to get up to the square roots before the sucker is there. Like I said, 55. 55 is not prime because 5 goes into it. And yet, and this is a simple example, but if we did the algorithm we just talked about, we would be checking 7 before we kicked out of this process, right? Because a for loop goes all the way up to the square root, the integer square root, which would be 7.
I was making the assumption, Don, that as soon as something was determined to be to divide our number, then that kicked it out of the loop.
But therefore, would it be a for loop then?
No, it would be.
You
it would
see
be
my
an
red pop?
yes.
Yeah. You see what I'm trying to get across? The fact comes out to be, and you might say, well, that's stupid. Who cares? It's one more check on the stupid 55. But no, if this number is huge, that is going to make a difference, and we're going to find that relative to this code that this individual wrote for us in class.
Well, and there are situations where it would have been kicked out at 2, and we don't want it to have to run through 9 or 11 or 13 to just.
As a matter of fact, if we do this right, with Ranjani's concept, we can actually embed that in the looping structure itself and not even have to take the loop itself may handle this situation for us. And I don't have to even do check 2 first. And if 2 does work, we're done. And I'll go 3 and skip. I mean, we may be able to play this game. You see what I'm doing? So I'm not going to even give you the code. We're not going to finish this up. We have hit answers all over this place. And it would be kind of fun for you to mess with that one to see what's going on. And Rajani, I agree with you 100%. That number theory concept, we lead them to see these things. And if we do this with freshmen or even middle schoolers, and we push this, this would have to be a pretty good mathematical group of middle schoolers to pull this off. But like I said, and you have to know my prerequisite was Algebra 1, so therefore I may be cheating relative to what your populations can be. So you may not, this discussion may be beyond what is appropriate for your students. That is 100% possible. I'm just saying with my students, every one of these conversations were great. And when they got to them in algebra or algebra 2 or geometry, all of a sudden, once again, they were the bright ones in the class because they already had these conversations and at the same level thinking as freshmen. They already did that, which is kind of cool. And they had fun doing it. I made sure they did. There we go. You will have fun. All right, here we go. All right, so that is the process for finding A prime. We do a loop. We check the thing, and if it mods by that value, what do? So if if 55 mod 5 is 0,
kick it out of the loop.
We kick out of the loop. So therefore, that is the condition. We don't put another if inside my loop, right? But but we have to check 2 things. This is why it's not a natural flag, because there are 2 possibilities. my divisor, right? The number, my num, and I've got my divisor here, right? So if num mod divisor is 0, that means
It's not prime.
it's not prime. What is the other possibility? What does my divisor do? It becomes
Large enough that it's hit the square root, and therefore that number is prime.
so if it is greater than the square root, then it kicks out. Do you see? So there's my while loop. It is a conjunctive statement. If this mod that is 0, we're done. Or if the number mod, if my divisor is greater than the square root of my number. And then it would kick out, and then I'd have to verify whether it was prime or not outside my loop, because there's 2 possible kickouts. One meaning we got it prime, the other one it's not prime. Everybody see that? So you could now think about writing that loop. Now for middle school or for younger, then you would just do a simple for loop going from 2 up to the number even, or 1 less than the number, or you could play the game in a very simple version, okay? Now remember I told you the intellectual leap? Here's the leap that is out there. Now, what if I wanted to print all the prime numbers between 2 and 10,000? So what is the quickest intellectual for you? What is the quickest answer to that question?
And you don't care if it's not efficient?
Well, that's the quickest means it's probably not going to be efficient. So yeah, what is the most natural, quickest way to solve what I just gave you? And efficiency doesn't count right now, yes.
Create a list of all of the prime numbers between 0 and 1,000.
But good luck, you have to be correct. But how do we let the computer do that for us, Dan? Well, you figured out how to know whether a number was prime, right? We just got that, we've done that. So how do I now find out if the numbers between 2 and 10,000 are prime?
So you got to put it in a loop that checks all numbers between the range that you're looking for.
There we go. We could do Johnny's thing if we're smart. We could skip and not do the even ones. We could start at 3 or something like that and skip on it. But we would just stick this honking while loop inside of a for loop, and we got it. It would check 3, do the thing, prime, not prime, 5, and if it's prime, we put it in the list. We do that, right? We could do that, and that would work.
And then you could have it print at the end.
Yeah, and print at the end. Yeah, keep a track of it, or just print it as it develops. Only print out the primes when they find them, or put them in the list and print out that whatever way you want to do that. That would work. I mean, quick code. It would be just like our earliest example of having how many scores above average, and we had 100 variables. Here we go. That's that solution. What is cool is some sucker a year or 2 before computers were invented, Aristophanes, came up with an approach that was just slightly more efficient, like insanely so. And what I want to do is I want to kind of show you that if you have your code, you can look at the stuff, and I will, let me share here just a second. I'm going to share the screen. You may or may not have loaded that one up because I have not done it. Here we go. I want to share screen 1, and then I'll put it up here.
Is it the one that's called 200 prime sev? Yeah, Tensa.
Yeah. And what he did was, if you look at this loop here, you can look at the screen. Method 1 was the brute force method. He actually didn't even do the while loop. He really did brute force. We did a for instead of a for. And that's in for loops where like our beginning discussion was kind of going through. And he went all the way up. I mean, he pushed it the worst it could possibly be. But oddly enough, even improving this is not much improvement. You could try this on your own to tweak it. The cool parts here is that this also talks about how to do some time components. Now, Python has built-in little things that will do a timer for you as you're running this code. I don't want you to look at the sieve yet, please. Try not to look at the code, although probably looking at it wouldn't tell you much right off the bat. But if we run this thing, and it's going to take a second because it will run here for a little bit, and it's going to give us how many seconds it took to do the primes kind of the least efficient way possible. And what you can do is adding your approaches to this. So it took 17.3 seconds to do it with very inefficient way. And it took 0.006 seconds to do it with a sieve of Aristophanes. Interesting. Now, how in the heck did we make that transition? You could say of course, we know that it is going, and I'm going to kick this screen off so we can get back to this, and we can come back and forth between that. But we could make that stupid nested for loop more efficient, but it's going to cut it down to not even half the speed. It's still going to be like 9 or 10 seconds length versus 0.006 seconds. So what is Kirkwood teaching you? We're supposedly talking about the stupid thing, Boolean array, and he spends a half hour talking about this other stuff that seems like it has nothing to do with that. It's called a hint. Okay? So what Aristophanes started with, now think about a Boolean array is an array that has true or false values. That's all it has. So what could we create? Remember I told you drawing a picture and labeling it frequently ends up being 9/10 of the battle. It's an easy part of it, but for some reason, all of a sudden we go, oh, and that happens unbelievable number of times. So Boolean array, prime numbers 2 to 10,000. So what could we draw? What could we draw that would have anything to do with a Boolean array and 2 to 10,000, but I'm going to shorten this puppy up because we're going to do some actual things with it. But what could we do?
Relation to this prime number algorithm?
Well, I'm not worried about any algorithm at all. I want you to tell me what the array would look like, what would I label it, and what would be the contents of my array.
Okay, so if it's the index would tell you which number you're looking at between 1 and whatever your upper limit was.
So these are my numbers, okay?
And then the content of each, the contents of the list would either have zeros or 1 based on whether they are primes or not.
Okay. We can do T or Fs or zeros and ones or whatever you feel comfortable with. We can use the characters T and F for true and false. We can use 0 and 1 for that, depending on where your students are and what you're doing. That's cool. Right now, we're not worried about syntax right now, so I'm going to use T's or F's. So we're missing one part of the puzzle. What's that?
The name.
The name of the chart. And if those are trues or false, what does this mean? What is the name of this chart?
Prime or not.
There we go. Well, or just call it prime. Because if this is prime, you would say prime number 2 is false. That's what I want to say. Or true, because we're starting there. Prime number 3 is true or false. Prime number 1,000 is true or false. That kind of makes sense, right? So
I don't know. I would like a question mark or something in the variable name.
So something that I picked up while I was in college was for all Boolean values, I always have some leading word in front of it that is like is or was or can be or something. And so I would personally call this is prime.
Okay. I like
so that would make
being a verbiage of being a verb is it makes it read really cleaner. Yeah.
No, I want to second that. It brings me more satisfaction to see an is.
And by the way, notice what we just said. Labeling the sucker is really, really important. And doing whatever makes it clean for you and for the student, that's what matters. And that's why we really, it seems kind of like mundane or little, that doesn't matter. No, but it makes a huge difference. And especially when you get writing this code, it's going to be, when you're embedded in the middle of something, it really makes even more important difference. So I think that's fantastic. That's exactly what we should be doing. All right. So now, one of the things is I always tell the students in this case, I'm not going to worry about Aristophanes says he was a year or two before computers, so he didn't know 0 and 1 were involved with this whole thing. So we're not going to even think about them. We're going to leave them blank. We're going to start with 2 all the time, just to make it easy. And Aristophanes kind of flipped this on its head. He flipped the logic around completely, and I'm seeing how far I can go on this thing. And we're only going to go to 100 just to make it easier here. Are we seeing, are you guys seeing all those numbers or not?
Looks good, Don.
Is it okay? All right. Trying to get them on there. Yep, it's pretty clean. Not great, but you can sketch out your own anyway. This is only, you guys will probably be a lot better at this than I am trying to do here. That's one thing you'll have to figure out on your own, I guess. So here we go. Aristophanes flipped it over. Instead of saying, aha, is this number prime? And then is this number prime? And then is this number prime? Aristophanes, and some of you have done this with me in class. Let's see if you can pull it out or you've done it on your own. What did Aristophanes do that was brilliant relative to solving this problem? If you don't, let's go over it. He flipped the logic upside down, which is what I tell students is fantastic to think about. He said, instead of getting rid of primes, not finding out if a number is prime, start with the first prime and get rid of all of its multiples because they can't be prime. So what he did was, and notice, thinking about tally arrays and looking at a pattern, trying to find an algorithm for something. That's what we're doing. The algorithm for this is, I'm going to set up and start with every number is prime. So I'm going to make 2 and 3 and 4 and 5. I'm going to start off by initializing all of my numbers to be prime. Because until I prove that they're not, they are. Okay? And then I start with the first prime number, which is a definition, right? We're given that. That's a definition for us. Like Euclidean geometry, if Euclidean geometry was actually right. So here we go. We have the axioms, except one of them is wrong, but that's okay. So here we go. So what he does was 2 is prime. Now mark off all the multiples of 2. Because if they're a multiple of 2, they can't be prime. So what am I going to do? Hands-on, what am I doing? And then tell me code what I would be doing.
Well, cross off all multiples of 2. So you'd cross off 4 and 6 and 8 and so on.
And when we say cross off, we just make them false. Because is prime 6? No. Is prime 12? No. Everybody there with me? Now, syntactically, what would I be doing there?
Another for loop.
Ah, now is Judson just pulling an evil Kirkwood on you? And that is that it looks like a for loop, but in reality, it's a hidden while loop, and he's just lying to you, and he's learned from me well, so therefore that's what he's doing. Or is it really a for loop?
Well, we have a max-min range that we want to run this process on. So we know the number range, so that should be a for loop, right?
And is there any kick out earlier on, like the primes, right? We thought it was a for loop, and then there were times that it was kicked out earlier. And so, but in this case, do we ever want to kick out earlier?
Well, the difference in this problem is the minute you get one factor, when you're just checking one number, you can kick out. But in this case, you're trying to find all of the primes, so you're not going to be able to kick out.
Yeah, I don't want to kick out until I finish the whole beast. And we'll figure out whether that whole beast has some variations in the theme in a little bit, but the fact is no. So therefore it is going to be a for loop. Yep, we're going to do a for loop, and think about that. It's easy. We're at num, so we start at num, and I mark up. Now think a second, please. You might even jot yourself down little notes. And by the way, this is through experience, both of correcting thousands of students' problems here, and probably, I can't even remember that far back, but I probably would have done this too. what would be one of the mistakes students make on marking off 4, 6, 8, 10? Starting with 2 and marking off its multiples. Or let's verbalize that in another way. That may work. Or another way, what is my for loop going to be to mark off the multiples? So with 2, my number was 2, I marked off 4, 6, 8 up to 1,000. Or we're just going to 100, right? So what was my for loop structure going from, or how is it organized?
For index from 2 till the upper limit.
Okay, so we could go from 2 up to, and what am I going to do with this?
You need to do plus equal 2. Is that what you're after?
Pardon?
You need to do plus equal 2.
So you would say, okay, so this is going 2. So on your for loop, instead of going 2, 3, 4, 5, 6, you're making the for loop go up by increments of 2. Everybody see that? That makes sense? So we're making the for loop go 2, 4, 6, 8, 10, 12 up to 100, which we can do. Okay. Now, careful, because what do I really want to make sure I don't do?
Would you mind indulging us in actually writing this in Python syntax?
Oh, okay. So which one? This version of this?
Yes,
So
with the index moving at, skipping.
Can you see that? I can't tell with the, so index, for index in range, let me see above there. No, we can't. In range.
You've
So
got
what
room
would
to
our
your
range be?
left. You've got
What's
room
that?
to the left of the chart as well.
Well, can you see it over here better? Yeah, you can.
Yeah.
All right, 4. And what I'm gonna call this divisor, if you don't mind. And we're divisor in range. Now, how do I create this? Now, this is going to be the key point. So, in here, what I'm going to do is I'm going to say is prime. And we can do true or false or zeros or ones or everything else. I tend to like to use the letters, so I'm going to say F.
You need it not to include 2. So you
Okay.
can start at any number
Okay,
higher
good.
than 2.
All right, we'll just talk about this. And so this was divisor and equals false. Okay. You just hit upon, in whatever way I do this, and there's a couple of approaches, I want to make sure I don't do what? Cat?
Include 2.
Yeah. The most common mistake students make is they will wipe out the one they're working on. So, and we wrote the numbers 2, 4, we were writing that, and that's because I was thinking one way, but then you guys were telling me to go another way, and we'll come back to this in a second. But I don't want to start at 2, I want to make sure I start at 4. Okay, so I'm going to just do this concretely, and then we'll generalize if we get that. So how would I do 4, 6, 8? So I would go 4.
Yeah, then you need some way to add 2 to the number each
well,
time.
The 4, yeah, we haven't done compounded or when I showed you the for loop earlier on. How, by the way, could we find this out? Without me telling you guys right now, what could you do right now to find out how to increment the for loop? Where there's actually 3 pieces when I introduced the for loop. There, you have a simple version, which just you put like 4, 5, and it's going to go from 0, 1, 2, 3, 4. Quit, correct? The second version was, if I want to go from 3 to 20, how would I do that? If I have a for loop, I'm going to go from 3 to 20.
Well, your range starts with your low number and ends with your high number, right?
Okay, so what would I do?
4 and, well, we're doing 4 and 100, right?
Well, no, well, but the 3 to 20, I want to do, what would I do? Careful.
You do anything over 3 to 20. So you'd probably go, you said you could do 6.
No, but I want to, no. These are two separate problems. We're talking two different weeks. Sorry. This is just completely little simple precursor problem. If I want to do something in the range, I want to go from 3 to 20. How do I write my syntax? For num in range in the parentheses.
Just like you have it 3, 20, right?
Careful.
Uh-oh.
That's a tweak I'm doing on you. I'm being evil, but that's the tweak I'm doing. If you want to go from 3 to 20, what do you have to write in the range process?
I think it depends on how much you're incrementing by.
Oh, we're not there yet. You're right. We're not there yet. I just want to go from 3 to 20.
Well, the for loops start at 0. So
yes, but I want to go from 3 to 20.
Right. So usually we like to start at 1. So maybe you have to start at 2 to be the number 3.
All right. Now we got, and this is part of the problem, but this is good because what's going on, what's going on is exactly what students would stumble around with too, right? You guys have not done, and you should not take, there's nothing personal at all here. You haven't practiced any Python at all. My God, we've done 4 weeks and you've been thrown into the pool and there is no water in it because you have not, no one's poured any in there for you. So don't worry about this, but the for loop went from its starting point. So if I went now, listen carefully. If I go for num in the range of 5, what is produced? What's num's values?
0, 1, 2, 3, 4.
There we go. So it starts at 0 and goes up to 4. So what do I do if I went from 3 to 10?
You do num goes from 3, 10. You need both numbers.
No, but if I go 3, 10.
Oh, 3 to 10. You want 3 to 10. You want 3, 11. Sorry.
There we go. You see what I'm trying to get across? Mike, we always called that an OBOB. And an OBOB is an off by 1 bug. And I'm glad to see no recognition in your faces. And sometime when we have more time, I'll tell you the stupid thing Kirkwood did. Yes, he is a typical male, not asking directions, and it has to do with OBOB. If you want to hear a story of me making fun of myself, which there's plenty of those, but this is a good one. But anyway.
Okay, so I thought that it would be 2 to 11 because I can never really tell where it's over counting.
Yeah, that's why we have to practice that. You're exactly right. It over counts on the end or under counts. Actually, if you want to think about this, when you go 5, it goes from 0 to 4. So therefore, yeah.
So it's using less than comparison rather than less than or equal to.
And or thinking it starts from this value and it defaults to 0 and you want 5 numbers. If you want 5 numbers starting at 0, that means you got to go 0, 1, 2, 3, 4. That's where it goes to. And you have to play that game. And only way to play that game is practice. You're exactly right. That's until you do it, you're going to get OBOBs all over the place.
So Don, were you going to tell us how to get it to skip every other one?
Well, yeah, we're getting there, but we couldn't do the beginning one, so there's no point skipping until we do the beginning one correctly. So yes, so we'll get there in a second. Yeah, so from the default is just 5, like for range of 5, and it goes 0, 1, 2, 3, 4. To get from 3 to 10, we'd have to go 3, 11, because it would go starting at 3 and go 3, 4, 5, 6, 7, 8, 9, 10. Kick out, and you're right, because the for loop is a while loop with less than the second value. Now, what is it? For loop in reality is a while loop with less than the second parameter. That's what it is. Exactly right.
So I'm confused, Don. If we're going from 3 to 20, and I count on my fingers 0, 1, 2, 3, then the 4th digit is actually stands for 3.
No.
But you said it's on the other end.
No. If we want 0, 1, 2, 3, what will we have to do in our for loop?
Well, we just say for range 4, right?
Perfect. There we go. So your range is one larger than the value you want. 0, 1, 2, 3. You'd have to say 4 to do that because we're getting 4 values because we're including 0, which we don't do in our numbering system, in our brains. So if you want 3 to 20, what is it going to be? Num in the range of 3, 21. Because there's actually 21 If you go from 3
But
to,
won't that start with 2 since 0,
no,
1, 2?
no,
Okay.
no, because when you give the first number, good. When you give the first, if you go 3 comma 20, it starts at 3 and goes to less than 20. Because when you don't do it, if there's only, you're right. This is why it takes practice. If you do 4 num in the range of 5, what is it actually the same as? Well, we'll be using 2 parameters. Matter of fact, I tell students to do this at the beginning, just for practice until you're sure yourself, do this. What is exactly the same as 4 num in range of 5?
0, 1, 2, 3, 4.
So what would you do in the syntax? 4 num in the range of
6.
0, comma 5. 0, comma 5 is identical to 5 by itself. Okay? And we see that. Therefore, to go from 3 to 20, you have to go 3, comma 21. Okay? And that's a little weird. You're right. That's a little
Well,
weird.
does that just mean we're ignoring the lower numbers? Because they're there. 0, 1, and 2 are there, and that just.
If we're doing an array, we're ignoring them, but we're just doing a for loop, so that's independent of that. But yes, you would just be or actually you could start at negatives. You could actually start a for loop with negative 5, comma 20. You want to go from negative 5 all the way up to 19. So I mean, you have that possibilities or integer values, so you can do whatever you want. So saying we're ignoring, if you start at 0, we're actually ignoring all the negative rings. So you know, our mindset has got to be of that kind of domain.
So by saying the range 3 to 20, sorry, I'm just trying to get this absolutely locked in. You're saying that that first number 3 is going to include 3 because that digit is actually 0, 1, 2. It's going to start below 3.
Correct.
Got it.
The first digit is the starting point if there's 2 digits. That's weird about the syntax. That's why really, in all honesty, I don't Python syntax. I struggle with a little bit. There's several places like not having the do loop and this. I don't think were really great design issues. Of course, once you practice them enough, you don't think about it at all. But the reality, I think the language could have been a little bit more written in a way that would be cleaner. Put it that way. Somehow they didn't ask me. I don't know. I don't understand that. That's okay. So
this is not an uncommon thing in programming languages. Java does it with strings. And what I tell my students, whenever you are going between a range, in most programming language, the first number represents start at, and then the second number represents stop before.
Before, yeah. And which is a little quirky, but that helps, yeah.
That's helpful.
Yeah. And then the third number, if you put it in the set, is the increment. So if you want to go from 2 to 20, you go start at 2, go to less than 21 by 2s. So in your range, in the range of 2, comma 21, comma 2. The third parameter in those set of parentheses gives you the incrementation, how much you were going to skip by. So that would go 2, 4, 6, 8, 10, 12, up to 20, and go to 22, but that's greater than, if you're going to 20, it's greater than the 21, so you kick out 2, so you kick out, and it would not go there. All right? So 3 parameters, start, kick out before, and increment.
All right, now we have our answer.
Okay, so now we have that answer up there. So everybody now see that what we've got is we have one for loop that we can do this. So ours would be 4 to 101 by 2s. Correct? Everybody see that now? Makes sense. That's why I backed up to these easier examples before I wanted to get to this larger one. Okay. Now, I should put a pattern. Since you chose that, I'm going to go that way. With 2, we went from 4 to 100, and we did this. Some of you may, with your students, you may want to even write that out to say that was 4, comma 101, comma 2. So they see syntax and patterns. Now, what Aristophanes did then was pretty wise. So now we did 2, and it knocked off all multiples of 2. Everybody feel comfortable with that way? And we had to make sure our algorithm did not, I liked what you did, it did not knock off 2, because we can't make 2 false, or we've lost everything. The program will end up saying nothing is prime, which, by the way, is a fairly typical response the first time kids run this program. Okay, now, what do you think logically he said to do next?
Do the same thing with 3s?
Why? Why did you choose 3?
Because it's the next number.
That is after 3, are you going to do 4?
No, because it is a multiple of 2.
Because I don't care whether it's a multiple of 2 specifically. I do care that it is
even.
Well, it is not a prime. I don't give a rip whether it's even or not or anything else. It is not a prime. So what you do is, yes, you go to the next number that is still prime. So
that makes sense.
So we go to the next number that's still prime, 3. Aha. And what do I do with 3? So my number is going to be 3. I want to mark off
three.
What would I mark off?
Well, any multiples after that that haven't already been crossed out. So 9 would be the next one.
Okay, okay. You're getting ahead of yourself, and we'll get to that stage maybe, depending on time. But let's do the simpler version of it, if you don't mind. Because we're getting, once again, we leaped off, and let's just leap into the kiddie pool for a second here. So the first thing I would mark off is, if I stay consistent, I'm just marking off the multiples of 3. Right? And then we're going to come back to your, you might want to jot yourself a note not to forget that, but we're going to mark off multiples of 3 at first, 6, 9, 12, ... up to 99. So we did what? 3, our looping structure, we started at
6 this time.
6, and we went to
100.
100 or 101. We can do whatever we want as long as it's, because we know it's going to get 99. So and we're going to go by
3s.
3s. Correct? Everybody there? And that would mark off 6, which would, and I'm going to do this because it would be redundant. It would mark off 6, which was already marked off. And it's going to mark off 9. And it's going to go mark off 99. And it's going to go down the line, right? And so it marked off all those. Beautiful. Then the next step. Does everybody, we have the rhythm of this problem. We're going to go to the next one that is still prime, which would be
5.
No. Yep. Oh, yeah. Excuse me. My fault. Yes. 5. I would say no. And you go, what? I thought I finally understood this. And now he said, no. What do you know? Yes, 5. And then we would continue that process. Cool. Would that work? Does that sound like a logical approach? I mean, this is kind of slick. What questions do we need to ask ourselves relative, going back to Johnny talking about the stuff for efficiency? What about this do we need to think about? We need to think about, how far up the line do I need to keep checking? I'm checking 2, then I check 3, then I check 5. The next one I will check is 7. Then it will check 11. Then it will check 13. Then it will check 17, and then 19. How far do I need to keep going all the way up until I get to 97 or 91?
No, we already did that part of the problem. It's the square root of 100.
So notice, if we have that conversation early on when we did primes, then we now know, even now this is expanded into a radically larger piece of the puzzle, we know that we actually, if I'm only going to 100, if I went to 10,000, I would only need to go up to
10.
No, if I was 10,000,
oh,
I need to
sorry.
go up to 100. But if it was
Right.
100, I only need to go up to 10, right? Exactly right. And there's another part of this puzzle. What else was inefficient? And Kat brought it up.
There were already some that were crossed out. We crossed them out twice.
As a matter of fact, if you think about some larger numbers, we may cross them out 3 or 4 times, right? If there's something that's a multiple of 2, 3, and 5, right? 30, we would have crossed them out 3 times, right? So is there a way to avoid crossing them off. Now I'm going to give you one hint because of our time control here, and then I want to see if you play around with this. What is the first number with 3 that is not redundant to cross off? What's the first number with 3 that is not redundant to cross off? I.e., we have to, otherwise we're going to mistake.
9.
There we go, right? Because 3, we don't cross itself off, obviously, but 6 has already been crossed off. But when I get to 9, it hasn't been crossed off yet. Cool. Now notice what we're doing. With kids, I would let them sweat over this a lot longer than I would let answers pop out all over the place when we discuss it. With you guys, time is of the essence, unfortunately. So what's our next prime? 5. What's the first, this is interesting. What's the first number with 5 that we need to cross off? Otherwise, we're going to screw up our algorithm.
15.
Careful.
Not 15. Not
why,
20.
Why not 15?
Because it's divisible by 3.
There we go.
25?
There's not 20 because that's 2. So let me see. 3.
Ooh, 5 times 5.
If we kept a chart of this, we might see this answer, wouldn't we? And do you see the benefit of saying, sit, if you guys want to, we'll sit and brainstorm. If you think you got it, you got the best go. And I gave them the timer and stuff and said, whoever's the fastest in the classroom gets 5 points extra credit on this problem. Just go. And then anybody who sat and discussed with me, we would start. And do you see by seeing that, building a chart, and some of you went, others you're going, well, I don't get it yet. Well, because it may take a little bit more rhythm. What's the next prime that we need to use to cross off after 5?
7.
7. And what's the first number with 7 that I must cross off? 14? No. 21? Nope. 28? Nope. 35? Nope. 42? Nope. Golly gee, 49. And you see, I like Ranjani's earlier statement about having, a number theory stuff. Can you see how they are learning number theory here? All of a sudden it matters. It's not just learning and playing with it, it's doing real things. And it makes a difference because they're really competitive and want to make this thing fast. Okay? Now, that's the end of our time here because we're going to pop in and let them have a little discussion. I just want to make sure everybody says, so you can look at the codes, look at stuff and look at the syntax, see what's going on. And if you want, talk to me and we can set up another thing. I think by the response for several people, I will kick out like a 4-week lesson plan using a graphical interface and introduction and send that out to you with all the material. And I'll send that out to you probably by the end of next week, get it formalized and do that. And then I will probably gradually add a month at a time to that fairly quickly and get it to you. If the people say, yeah, this is good, I want it. If you say, I thought this was going to be good, but we don't need it, cool. I just won't take the time to put it in polished format. Okay, so let me know. And if you can't let me know by tomorrow, then that means it wasn't that important to you. So that's okay. All right. And now we have our 2 leaders. I was going to say fearless, but that's only Kathy, so that's all right. So here we go. Our 2 fearless leaders, and they wanted to talk with you stuff at the end here. Go for it.
Thanks, Kirkwood. Thumbs up if someone can hear me. Oh, right on. Last minute questions.
You're just showing off your fancy mic.
Yes, I am.
Don't give me this crap, Ken.
Kirkwood knows me enough, right? Can you see my fancy mic? I want to leave room for questions because the information that Kirkwood passes on is super, super important. Do you guys have any last minute comments, questions for Don? As questions will come up, I'm sure as they will, you have his email. He is sometimes slow on email. No, just kidding. But he does answer you eventually. So
Kathy, the rest of you,
right? It's just me, right? Another one who gets inundated with email from me is my friend and colleague T. Smith. I am super blessed, as I said yesterday, to know both of these fellows. These are your leaders of the Oregon CSTA. They have been from the very, very, very beginning, many years before I was even born on this planet. I say that, it's kind of funny. But I told T that he needs to come a little early today because yesterday, at the end of yesterday's session, as most of you were there, I think, yes, there was a lot of discussion on, gosh, how are we going to do this in the fall? And what better way than to ask someone who's still in the classroom after 45, 43, 40, I can't remember, 40 something. I'm losing track now. So T. Smith, you get the last, 10, 12 minutes or so. School us, learn us, tell us what you know after 43 years of being in the classroom. Can't hear you. Hold on just a second. I have to unmute him. See, I muted him before. I have the power now.
This
There you
technology,
go.
this technology. Yeah, someone kicked in 42 years. Yeah, that's true. And there's a whole story behind that. But the key is that I actually use teaching computer science as a way to kind of do a teaching and learning lab. And I use it through computer science. I throw a lot of stuff on the wall. It doesn't all stick, but some does, and my students benefit. And so, and many of you already know this, your administrators don't come by your room very often. You know, if an administrator, when Don was teaching, if they went by his room, they would keep on walking. You know, I really don't think they probably spent a lot of time there, and maybe not in your classroom either. It's not easily understood. So that actually gives us an opportunity to try things, to be the leading edge of teaching and learning. And I've done that, and that's one of the things that has kept me kind of refreshed through the business. As I mentioned yesterday, or to other groups, you know, I use OCSTA as my training ground, and really exclusively. Yes, I go to NCCE and NECC, OCSTA, SIGC, and so forth, or CSTA and 6E. I do go to those, but you know, and I pick up some things there, yes, and it's worth the trip. But most of my professional development has come through OCSTA, so take advantage of it. We've talked about it. We're going to offer some additional opportunities in the future. One comment, and I think I probably said it yesterday, but I think it's important enough. I am when I was sat through teacher prep or teacher professional development a few years ago, and Sherwood School District says, we are going to look at education through an equity lens. I didn't jump on that bandwagon. I thought it was a burden. Okay, so you're going to require me to recruit underrepresented populations. You're going to require me. And I saw it as an add-on. I saw it as a burden. I mean, not a great burden, but I saw it as something extra. I've come over the last couple of years, I've changed that tune a bit to say that it's not a burden, but an opportunity. The students who gain the most, have the most to gain from what we offer, are those lower socioeconomic students, the students of color, the women who may not have that opportunity because the culture says this is not your thing. Those are the ones that have the most to gain. I can tell you that probably 20% of the students for this next trimester may not even need me. Period. They're high flyers, and they could probably do this on their own, but that the frame is what they need. The frame is what they all need. And so the idea of equity, bringing those underrepresented people in to our classrooms is, you know, it should be our mission. And I'm going to say, I'm going to own it. It's my mission to kind of reach those underrepresented populations. All right, folks, that's all the happy stuff. Here's the frustration. I don't know what, and I would say the hell I'm doing this fall, but you know, I'm going to stay professional and not use hell. But I don't know what I'm doing this fall. My administration has told me, yeah, ODE says you have to have synchronous online teaching until when? Well, until 3 weeks of the COVID testing is down below a certain level, blah, flickin' blah. And so the point is, how can I plan this? And then all of a sudden, boom, I'm dropped out of this online teaching into a hybrid model. And in Sherwood, I'm teaching a week on and 2 weeks off. I'm in the building what does that mean? I'm in the building 1 week and then I'm off 2 weeks. In the hybrid, am I supposed to teach from my classroom? Will they allow me to teach from home or to teach from Sun River? what will they allow you to do? I mean, there are so many questions. And the definition of synchronous learning or teacher-led learning it's going to be interpreted slightly different, maybe more than slightly different from district to district. And I've had one district, more than one teacher tell me, hey, I'm supposed to be teaching from my room. I'm going to be 7:30 to 3:30 in my room as I would be, but I am teaching online. And another district says, hey, you know what, no big deal. I mean, you're professional, you can teach from anywhere. Where are you on this scenario? It is so unsettling that the teachers are, we had a union meeting, a union gripe session on Monday evening through Zoom. And honestly, it was a gripe session. There was the intensity that I have not seen in a long time about teaching issues. So I'm living it because I'm a union leader, and I'm I'm involved with that leadership and fielding those questions and what are the answers and how can we do this? I say all that to share your frustration. I can tell you that Sherwood School District's taking in a liberal interpretation of the teacher-led synchronous instruction, and that it's not 45 minutes of online face Zoom with the students per period, but we are going by periods. If that's the case, there may be more of a flipped blended opportunity. Will relieve some of that concern about being online so long. And so I'm going to just leave it at that. And I haven't, I left you 30 seconds to share out a little bit, maybe your own frustrations or maybe solutions, but that's what I'm facing.
Anyone want to comment, add, gripe? Nobody?
I shared yesterday. I don't want to share again.
Fair. In fact, here's what we're going to do. We're going to do this. So that, stay with me. That concludes our intermediate advanced Python session.
Sorry, I didn't want to